Hello, and thank you for watching this video. What I would like to talk today about is code quality, and more specifically, code structure. Code structure is a very minute task when building software, but it drives such a burden on the success of the quality and maintenance of your code that is very important to get right. In this video, I'm going to cover 3 different ways that you could structure your code. Those being a single file, all of your code is written in one or a few giant files. Sock drawers, your code is organized by the type of code. And functionality, your code is organized by the functional domain or subset that it actually lives in. Now hint hint, all of these might be fine under circumstances of development, but you shouldn't ever consider your code complete until it is of quality. Before we jump into the code, let me explain what we are going to try to build. We are creating a REST service endpoint that is going to perform a REST call to a backend server called Swappy, which is this cool public API serving all types of Star Wars content you can try to use for free to see what you want to build. Our endpoint is going to take in 2 query parameters. A Star Wars object type, which is either people, planets, or starships as their API specifies, and a number, or a num for short, which is a unique identifier. Now let's talk through these scenarios and how we can implement it. Alright, I'm going to go ahead and open up the bad single file structure here. And in here we have our big giant server.ts. So what this file shows is one giant asynchronous function called init. And within init you see that we initialize the server, we create the route. The definition for the route handler is also in line, and it's doing all of its logic all in this single file. So we see that we receive a request, we look at what the request looks like, make a decision on how to respond to the client based on the quality of the request and make sure that all the properties are defined. We also perform the request, so we go to an external service and ask for specific data based on specific query parameters that we're passing in. And then afterward, we also do some data transformation. So you see that we take the result and then we combine some of the data fields or kind of manipulate them to create new properties that our client or our user is useful or looking for. And then once that is all complete, we return the data. We do have a global error exception in case something goes wrong. So what is wrong with this code? So obviously you don't generally want to try to just have all of your code in one giant file. It makes it very hard for end users, developers that are trying to come in and learn your code to understand where they should put additional logic. And if you want to make your code a little bit dry and try to reuse some of the functionality, it's really hard to actually make your code dry and consistent because everything is in one file and it's hard to keep track of who's using it, how, and just really hard on the readability scale. Some good things about this though, so if you're trying to figure out how something is going to work, this is a very easy approach to get started because you can actually just test to make sure that from the input you can create the output and you can make sure that all the integrations that need to happen actually can happen. So doing this from an extreme programming point of view where you're trying to make something work and then you worry about making it fast and making the quality later on, this is actually a very good approach to write code. However, you never want to say you're completely done with your code when it's in this structure. You really want to take the time to split it apart and identify the different types of codes that you can reuse some of this later on. So I'm going to go ahead and switch over next to the bad socket drawers code, and in here we open up source. What we see initially is we do have the server.ts still, but then you can see what we have is all these different stereotypes. So stereotypes are a type of code, they're a way of identifying what the source code in that file is actually going to contain. It's really used for consistency and identifying structure in your code. So you can really open up a handler or a route or a service and you'll know exactly what you're going to find. It kind of states the patterns that your code is going to follow. So like I mentioned, we have this server.ts and then next to it is all our different stereotypes So these are actually what we call sock drawers, because a sock drawer is you open it up and you see all of the types of that type together, and you can look at them all. They all have different types of functionality, but they're all performing it the same way. So let's just walk through this really quick. So if we open up the server.ts, the server is responsible for doing the initialization, getting the routes, and starting that. So that's basically all we want it to do, is we want it to do as minimal as possible, since this is a heavy integration point in your code. It's the actual execution of your server, which is going to inevitably go and collect the rest of your source code and create that server for you. So we're going to go jump into what the rest of the files look like here. We have a swappy.router, so you can tell the naming convention follows the sock drawer, the stereotype name, and then we have the functionality first. So in the router, we have a single route defined. It's the same as before. This route is basically a GET request, and we're telling the handler to actually go to a separate handler file and handle the request. So to actually get the context of this request and see what the code looks like, to navigate it through the file system, we actually have to go up a level, and then we have to go into handlers, and you can see we have the Swappy handler again, functionality, stereotype, and we can open that up. So you can see here that it's doing the same logic again as the other giant file, except what we're doing is we have a utility that's going to validate the request. If it looks bad, it's going to reject the request. And then we have a service that performs the REST call externally. And then we have another util that transforms the response based on what we're interested in. And then we have that global exception handler again. So you can see kind of how all the code comes together. Now just to go through the last two files, we do have a Swappy Service. The Swappy Service is responsible for taking in the input and then creating the REST call and getting the response. That should be all it's doing, is taking whatever the input parameters are to go to that external system, and then performing the REST call correctly, making sure that all validations happen, and then returning the data. We don't want it to do anything else. And then the last file we have is the utility. The utility has all that synchronous, pure business logic that we want. So right here we have a validate request, which again takes in that validation and makes sure it's a good request. It returns false. It's a bad request, otherwise it returns the request parameters in whatever shape or format that we like. And then the transform response is actually taking the response of the service call and then creating the data in the correct structure for us to return to the client. So what's nice here is these functions are very simple. You can see that we can expect very simple inputs and outputs, and we can actually create the transformations as we need. The only problem that you'll probably recognize is, now that we have all these sock drawers, like how do we add on code, or if we have to add new stereotypes, how do we really follow the logic? And the tricky thing with sock drawers is these all grow indefinitely, so we're going to have an indefinite amount of handlers, routes, services, utils across our entire application as it grows. And it becomes a little bit more difficult to track the logic of jumping from a utility to a service. And one thing that's really hard for junior developers is they're not always really aware of where that code should go when they get a new user story or trying to implement a new feature. They kind of insert it where they think just makes sense to get the problem done. You don't really have a hierarchical way of structuring your logic. You just have these big sock drawers or folders. So you don't really have nested at all. You can't say that there's a subdomain to your specific functionality. It all just kind of grows into these giant drawers. So that's the big problem, is scalability. Your code can't scale very well if you go the sock drawer approach. A benefit is it gives a lot of consistency in tracking the types, but overall I'm going to say this pattern is pretty bad to use, just because scalability is very important when writing code, and having that ability to track where business logic should live or reside, instead of just creating one giant utility that will have all the logic for the rest of time for a specific domain, doesn't quite make sense. Instead, you want to make that hierarchical have subfolders so you can organize your logic a little bit better. And the last type that we have is I'm going to go ahead and switch over to this good functionality, and I was kind of alluding it to while talking about sock drawers. But the whole idea is you really want to keep track of the functionality of what you're trying to achieve in your application. So you can see we have a server.ts still. This is exactly the same file as the sock drawers. We actually have the router right next to it. The reason why the router is next to it is the router is a function of your server. Anything that comes below that is a sub-function or a functional flow responsible for another piece of logic that doesn't sit at the server level. So we have the server and the server router, and then each functionality domain is a subfolder of that. So we have Swappy, which again is this high-level view of functionality that we could have subfolders underneath for various logic that might reside in Star Wars API as we build in more logic and more endpoints. But for now we have this dynamic one that can kind of look up any type of data or identifier in Star Wars API that we like. So what we do is in this Swappy folder we have all the logic specific to that Swappy domain of functionality all grouped together. So what you can see here is we have the handler, we have the service, we have the utility, all residing in the same folder, and it makes it very easy to follow the code structure on what this is trying to do. So as an engineer working on this project, I should know that an entry point into the Swappy domain would be through the handler. The handler would connect to the server through the server router, and that's where all my logic for this domain really starts. But then what's really nice is as this grows, I can create subfolders. So maybe I have create a new Star Wars character endpoint, or maybe I want to query all the starships with specific types of users and make more complex logic. All those can be different subfolders under this domain. And then we can create the structure of these different stereotypes living at different levels of our application so that we can really organize our code in a way that anyone can just come in and understand what the functionality of a specific domain is, or really track what we think the domains of the business really are at sub-levels. So that's my video. I hope you got a basic glimpse of how you might want to organize your code so that your code is scalable and very easy to understand. Again, I feel like this is something that is incredibly easy and important to get right. This really pushes how you test your code, how you split up domains as your code base grows, and how well you can scale. I would love to hear if you have any feedback. If you do, please provide any insights to me. Again, thank you for watching.